Pleasant day, everyone. So this is our topic for today, which is about molecular geometry and the intermolecular forces and bonding theories. This is in connection with the previous topic that we have, that is chapter 4 about covalent and ionic bond. Then this is followed by the representing of molecules, which has something to do with also with the bonding, especially for the Lewis structure in the writing of the Lewis structure. So this will be our topic, which is under lecture 6 or chapter 6. What are the outline of this course? Of course, we are going to describe what is molecular geometry. Molecular geometry has something to do with the shape of the molecule, okay? How it is being formed and how it looks like. At the same time, we are going to discuss also the molecular geometry and polarity. Then the IMF, that is the intermolecular forces. This is a kind of a bond, no, which has something to do with nonpolar compounds. Then we have the hybridization of atomic orbitals. What are hybrid? Okay, hybrid orbitals has something to do with which is not the usual formation of the molecules. Then the hybridization molecules containing multiple bonds. What do you mean by multiple bonds? It could either have a single, double, and triple bond. And the last one is the molecular orbital theory. These are the lecture outline of this topic. So what do you mean by molecular geometry? Actually, if you talk about molecular geometry, this is the 3-dimension, or this is the arrangement of the atom in the molecule, wherein we had to extend our imagination how it is being formed. No? We had already discussed this in the Lewis structure, no? Wherein we already know which will be at the central atom. For instance, this is beryllium dichloride. We already know it should be beryllium because we have 2 atoms of chlorine. So this is now the arrangement. So the molecular geometry has something to do with the shape or the arrangement of the atoms in the molecule. Is it in a shape of tetrahedral, octahedral, or is it in planar like that? These are the topics which is under this lecture. So this plays a very important role in determining the chemical properties. How will we know it will form a hydrogen bond? Of course, from this molecular geometry. So an example for this is, be sure that you should know how to draw the Lewis structure, the one that we have discussed in the representing molecules, because this is interconnected or it is related. No? So after the representation of the molecules in an atom, this will follow. Okay, so we already know in the Lewis structure that it should have what, Hila? It should have that octet rule. It will always follow the octet rule. Okay, it should have 8, 8 here. And no, this is beryllium dichloride. There will be 2, no, 2 lone pairs here. No, 2 lone pairs for beryllium because this is only 2 plus 2, 4. As I have said, it should be 8, so there will be 2 electrons here. So same thing here, no? Your boron, that is boron trifluoride, therefore there will be 1 lone pair. What do you mean by lone pair? Is a lone pair is the one which is not being attached with another atom. So there will be 2 lone pairs here in beryllium, no? In which case, if you are going to have this in the formation in a form of balls, okay, what will happen? This is your beryllium. This is your chlorine. Diba ka chlorine? Nganong ingana ang shape sa chlorine? Because there is na a pool, pool between this duha ka lone pair. and this is known as linear. Tawag ani nga shape is linear because it's just in line. Na? This is tetrahedral. Tulo. Okay. Trigonal. This is trigonal ang mean. Tetrahedral has something to do with 4 sides. Na? So, this will be your boron and this will be your fluorine. To discuss this further, it is being shown in this theory, and that theory is the valence shell electron pair repulsion model. Okay, what do you mean by repulsion? The electron pair repulsion. So tendency when in a molecule, no, if there are atoms, what happened is magbinirahay sila. So there will be electron pair repulsion. Okay, so that is VSEPR model. That is the valence shell. This is the abbreviation of the valence shell electron pair repulsion model, that VSEPR. So to minimize repulsion, each of the valence electron around the central atom, no, is located as far as possible from the other. So what happened is, kung balloon pa na siya, kani if this is linear, no, kinahanglan lagyo sila gamay. Ngano man, aron di sila mag-repel, no? Mag-repel, or dili sila mag tendency is it will pull each other. So that is the valence pair electron. There are many shapes. No? The first shape is linear. If you talk about linear, it's line in line. That's 180 degrees. This one, kani. No, kani. This is linear. No? This is the central atom and two the same atoms here. For instance, the one which is being shown, no, that's beryllium, and this is duhacachlorine. Okay, this is linear. What do you mean by linear? Straight lang siya, no? Then we have the trigonal. Trigonal is 3. Now there are 3 sides of it. Okay, it's trigonal planar, no? And in the trigonal planar, this is kaning sa linear, it is 180 nga niya, di ba? 360 man na siya because it's plane, no? It's linear. So this is 180. The angle here is 180. For the trigonal, it is 120 times 3. Nga naman, tulo man siya ka sides. This is 120 plus another 120, 240 plus another 120 is 360. Okay, that's trigonal planar. This one is tetrahedral. In the tetrahedral, there will be pila ka buok. Kani trigonal pila ka atoms. Na? There will be 1, 2, 3, 4 atoms. In the linear, there will be 3 atoms. In the tetrahedral, there will be 5. Ang tunga is known as the central. Sa tunga, then there will be another 4 of those atoms. Example for this is the carbon tetrachloride, the CCl4. Okay, so your carbon will be at the center and your 4 chlorines will be at the tetrahedral form. Kaning paana, ning paana. Mas gwapo ni siya if we can see it in the balls. Kay maklaro gyud ni mga mag-ana siya, na? Okay, but this we could not illustrate it because we don't have the models. It's in the school. So this is tetrahedral, and there is trigonal bipyramidal. What do you mean by trigonal bipyramidal? Meaning the bottom side is in a shape of pyramid. Okay, that's trigonal bipyramidal. It is kaningani sa iyang anak niya sa what you call this at the we call that one, if we had it at the center, that is tulo na siya kaana, that is 120, 120, 120, 360. And from end, the end to the center, it's 90 degrees. That's the measurement of its angle, okay? So this is trigonal bipyramidal. This one is octahedral. From the word octa, meaning there will be 8. 8 sides of that. That is upat sa ibabaw, upat pod sa ubos. Na? So that is octahedral. Each from first the atom at the upper to the center is 90. Then 90 also at the center. Okay. So before that, let us look into what is the meaning of electron domain. So, electron domains are electron pairs around the central atom. No? So, electron pairs around the central atom. So, this has nothing to do with the shape of the molecule. So, let us count now the electron domain. How many electron domain? There will be electron domain are pairs, na electron pairs, ang pair, na electron pairs around the central atom. But it doesn't mean if you have a double bond, you will have two electron domains. Usa ra gyapon siya, that is counted as one, na? Because these are classified as electron pairs around the central atom. So, if this is the central atom, no, A, no, so how many electron domains is A to this one? There will be 4. How are we going to count? That is 1, then 2, 3, 4. No? Because it has something to do with the pairs. Of course, there will be 2 pairs here, 1 pair, 1 pair, 2 pairs. Wala man siya giingon nga pila ka pairs. Basta electron pair around the central atom. So there will be 4 electron domain in the atom A. Na? It's the central atom. Okay, how about this? How many electron domain for oxygen at the center? So there will be how many? 1, then 2, then 3. Okay, 1. Okay, so that is what is meant by electron domains. Electron domains, electron pairs around the central atom. So let us go back to VSPR. VSEPR, no? The VESPR, that is the valence shell electron pair repulsion. So here are nakatong 6 ka mga shapes of the atom. Okay, that is the geometry. The right term there is no longer shape but the geometry. So for the linear, this one, this is linear. Okay, now the first one is linear. How many electron domains at the central? Of course, there will be 2. That is 1 and 2. Okay, so it's linear. So this is the band angle. No? Then for the trigonal planar, how many electron domain? There will be 3. That is 1, 2, 3. Okay, it has a predicted band angle of 120. For the tetrahedral, how many electron domains? Okay, there will be 4. Kana mo na siya center, di ba? There will be 1. This is the first pair nga niya, 1, then 2, 3, 4. Okay, there will be 4 electron domains. For the trigonal bipyramidal, there will be 5. Ano man, kanang kada na attachment from the central to the attached atom, that is counted as 1 electron domain. Therefore, here from this one to that, that's 1. Then kana nga 2, kana nga 3, kana nga 2, 4, and kana sa ubos 5. There will be 5 electron domains. And for the octahedral, there will be how many? 6. Let us count it out. It will be at the center. That is the central atom. That is attachment of your central atom to the top. That's 1. 1. Then the first side, 2. Second side, 3. Third side, fourth side, 4. This is 5 and 6. So always remember that in linear, there will be 2 electron domains. Trigonal planar, there will be 3 electron domains. In the tetrahedral, there will be 3 electron domains. In the trigonal bipyramidal, there will be 5 electron domains. And for the octahedral, there will be 6 electron domains. So electron domains versus molecular geometry. So the molecular geometry is the arrangement of only the bonding. No? Dili pwede ng wala siya makaband. Na? That is why it's called electron domain, na molecular geometry. The molecules, not the non-bonding pairs. It should be the bonding pairs. Kung ay lone pair, sa ibabaw, wala, it's not a bonding pair. Bonding pair is from an atom to another atom. Attachment of one atom to another atom. No? So for instance here, this is ammonia. Okay, so take a look here. So how are we going to draw this? No? So in drawing this, can you still remember, count all the number of electrons, the total valence electron. Nitrogen is 5, di ba? 5, then plus 5, no? Times, that is 5 times 1, 5, then 3 times 2, no? 3 times, no? It will be 3 man siya, no? That is how many electrons? That is 1 times 8 for the hydrogen, nitrogen, then 4 oxygen, that 3 times 2. It's only hydrogen which will have 2. The rest will have 8 electrons. So 8 plus 3, there will be 8 plus 3, there will be 11. Diba? The total valence electron for NH3 is 11, but it's plus 1, meaning 11. This is 6 plus 5. Oh yeah, 11. Then, because this is NH3, then plus. It is an ion. So if plus gani, minus gani mo siya total valence electron, there will be 10. So take a look. That is 2, 4, 6. There will be 10 electrons and 10. Now, 2, 4, 6, 8. No? 8. Anong 8 man? 5 plus 3. No? 5 plus 3, 8 electrons. Ana na siya. No? 5 plus 3, 8 electrons. So, how many electron domain in the nitrogen? There will be pila. No? There will be 4. Okay, electron pair man. No? But how many bonding pairs? There will only be 3 bonding pairs. Kana 1, 2, 3. That's bonding pairs. How many non-bonding pairs? 1. Na? This is 3 bonding pairs, 1 non-bonding pairs. Okay, so that is for ammonia. So let us have it one by one. The first shape, the first geometry, that is the linear. Linear electron domain, only one molecular geometry. So for instance here, the beryllium dichloride, okay, pila ka domain, that is 1, 2. Okay, so right now your Lewis structure, so beryllium, there will be pila ka electrons tanan. What is the valence electron of this? That is 8 times 2, 8 times 3. Tulo man ni siya tanan, no? 8 times 3, 8, 16, 24. So it will be 24 ka electrons tanan. So that's 2, 4, 6, na 8, 10, 12, 14, 16, na that 8, 16, 24. So 2, 4, 6, 8, na 10, 12, 14, 16, then 18. Yan na 18, 20, because there should be equal. Equal gud na siya, no? Ana siya. Nganong, no? Ang total valence electrons ani pila man tanan, di ba? Look into, can you still remember how to compute for the valence electron? Look into the number of the group. Chlorine is 7, no? So 7 times 2, 14. Then beryllium is in, no? Beryllium is in group, asa mga group ang beryllium? Beryllium is in group 2, siguro. I don't have let me have muna kung sa kong periodic table kayon sa wherein as a periodic table. So what happened here is, diba, chlorine belongs to 7. Okay, so 7 times 2, there will be 14, plus beryllium to 18. So 2, 4, 6, 8, 10, 12, 14, 16, then 18, like that. So mao na ni siya. No? So this will be your beryllium. No? This will be linear ang form ani. No? How about 4? No? If you look into this, kanila nga atom, no? How many bonding domains? There will be 2. No? How many non-bonding domains? Wala. Kaya wala mo siya lone pair. Okay? So, if you talk about this, how many bonding pairs? There will be 2. Non-bonding, wala. No? How about this one? No? Pareho na sila linear. This is carbon dioxide. Okay. Carbon belongs to 4, then oxygen is 6, so that is 6 times 2, 12, diba? 12 plus 4, 16. So 16 electrons na, that is 2, 4, no? 2, 4, 6, no? Then 8, 10, 12, 14, 16. Ana, unta siya. Pero what happened is, it should be 8 yun on 8 yun kada, na, there should be 8 for this. So what happened is, there will be a sharing. Na? Your carbon here, di ba? Napay duhangan hiya, electrons, mo transfer na siya nganha. Tapos na ay usa ka pair ngan hiya, mo transfer po nganha. Napay usa ka pair ngan hiya, mo transfer nganhi. Ang usa ka pair ngani mo transfer nganha to make it into 8. So for oxygen, that is 8. Oxygen on the left, 8. Oxygen on the right, 8. For carbon, 8. Okay. So how many bonding? How many electron domain? There will only be 2. That is 1, 2. Wala man ibabaw. 1, 2. So that is in a form of linear. So linear ni siya. No? So an example of a linear is beryllium dichloride, carbon dioxide, and we'll have more example of this. Then another example for the trigonal planar we have here. That is why it is needed that you should know how to write the Lewis structure, or else dili yun mo makabalo. Okay, here. So this is boron trifluoride. Okay, so if this is the Lewis structure of boron trifluoride, of course, it's very easy to see that it is in a form of trigonal planar. So how many electron domains? How many electron domains? 3. How many bonding domains? There will be 3. 1, 2, 3. Non-bonding, wala. Kay wa man kay lone pair. No? So, in a trigonal planar, duha siya kabuok ka klase. The trigonal planar, and the other one, that's normal. And the other one is bent. Kanang murag, pa, kuan pag-ayo. Pa, sa pangipayana, pa bend pa-ayo. Why? No? Because in what happened here is there is a lone pair. Katong lone pair, mubira to siya in a form that it will have this bent nga trigonal planar. For instance, this one. No? That is the nitrogen dioxide. Okay, so tanawa. Na to ha. Ang nitrogen is 5. Then oxygen is, pilang oxygen? 6. So 6 times 2, 12 plus 5, pila man? 12 plus 5, it is 17. But it is anion. So, it will be plus 18 tanan. So, that will be pila na tanan? 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. So, what happened here? This is already the Lewis structure. Kani is 8, gani siya, kani 8 pod, na kani kung paano mo sa nitrogen 8 pod. So, same thing, there will be pila ka na electron domain. Pila ka electron domain ni siya. Yung na po mo 2, dili. Nga naman, this is 1, 2, 3. Okay, no? 1, 2, 3. Basta pair, nasa shape pair. Okay. Then, no? How many bonding domains? There will be, how many bonding domains? Kanira, duha ra. No? Duha. Then, how many non-bonding domains? Na ay usa to as ibabaw, non-bonding. Kung ay electron pair. And this nitrogen dioxide na, is in a form of trigonal planar. Okay, so how are we going to predict the lone pair? Lone pair is this one, kani si babaw, no, na sobra. So the effect of the lone pair to the bond is it causes greater repulsions, hence decreases bond angle. So mugamay siya, na mugamay siya. For instance, we have here this example that is the carbon, no? Carbon, this is the carbon chlorate, CCl, CCl2O. Okay, that is this one. No? So what happened here is your carbon will be at the center. No? Count it out. Pila ang iyang bonding niya. That is carbon is 7, 7 times 2, 14. Chlorine is 7, 7 times 2 is 14. Then plus 4, 14, 18 plus 6, 24. So there will be 24 ka electrons kaniya. Na? Dili lang maklaro. Kung 24 ka electrons, this is nga kani, there will be 8. Kani plus 8, 8, 16. Then kani na double bond, 16. It will be, 24. Oh, it should be 24 ka electrons ganita na, no? So what happened is, due to the lone pair, na may lone pair ganiya, it will, kani, na lone pair ganiya, wala siya lone pair. Exactly siya. Kung na ay lone pair, what will happen? This will cause greater repulsion. Kay kani lone pair, kusog po siya mubira, no? For instance, this is carbon, no? Methane, this is methane. C carbon with 4 hydrogen. No? So, dili siya mubira. No? What will happen is, dako ang iyang band angle. Diba? Kani tanawa, ang band angle ani nila is 124. No? Kani. Kani is 109. Pero katong na lone pair tanawa, gamay. Kaya nga naman, ang angle niya is 107. Is 104. Basta, the more daghan ang lone pair, the more ang it will decrease na the band angle. Kani, this is the band angle. Tanawa ni, walay pair, it's 124. No? Kani, walay pair, walay lone pair, 109. Pag naanay lone pair, pila ang band angle? 107. Duha ka lone pair, 104. Okay. So, we are now done with the trigonal. How about the tetrahedral? So, in the tetrahedral, an example of this is kini. Kini. Okay. What happened is this is the carbon, this is hydrogen. So, how many electron domain? There are 4. How many bonding domains? 4 gihapon. Non-bonding, wala kay walay lone pair. So, kani mo itsura niya, the geometry, or this one. Okay. This is by means of the stick na stick and ball model. This one is just the plain structural form. No? Another, it's tetrahedral. Under tetrahedral, pila siya kabuok. Under tetrahedral, there will be three. That is the tetrahedral, that is the trigonal bipyramidal, and the bent also. No? Pero kaniya bent is naanay upat. No? Duha ka, no? Duha ka lone pair, take a look. Duha ka lone pair o duha ka atoms. Okay, so here. First, kanisya, this is CH4. Okay. Then the second one is the NH3. Okay. So may kuan niya, it's still tetrahedral. There will be 4 atoms here, and naana siya kani burot ganiya is the lone pair. So ang lone pair mo appeal po na siya og bira to the extent that the geometry of your molecule will be tetrahedral. It doesn't mean only kung ma'am kinahanglan gyud di ni siya og na 5 or 4 ka buok nga side. No, it's not, no. Basta na ay lone pair kanang lone pair ma-appeal na siya, na. Okay. So take a look. There are only 3 atoms here, but because of the presence of lone pair, na upat na ang iyang mo nang nahimo siyang trigonal pyramidal. Kay mo bira po ning kaning lone pair. Kani duha ka buk lone pair. This is the molecule of H2O, the water, no? So it will be bent in a way that because of the presence of 2 lone pairs, no? 2 lone pairs, because it will be hydrogen. No, hydrogen is 2 times, no, there will be 2 times 2, so this is 4 na, no. Ang oxygen kay 6 man, no, so 10 kabuk ni siya tanan, na. Oh, 6. Okay, what will happen? Oxygen, that is 2 times 1, 2 plus 6, na, plus 6, oxygen 8. So there will be 8 ni siya tanang ka electrons. Mo na siya makita nimo nga ni nga. This is 1, 2, 3, 4. No? And this is in a form of bent. Then, how about the trigonal bipyramidal? So this is the trigonal bipyramidal. Example is PCl5. Okay. The PCl5, this is your phosphorus. There are 5 atoms of chlorine. Okay. Na? So looking into this, how many electron domain? There will be 5. That is 1, 2, 3, 4, 5. No? Then how many bonding domains? 5 also. That's 1, 2, 3, 4, 5. Walay lone pair. No? And this is the trigonal bipyramidal. This is siso. Okay, kung ibutang nimo ni siya nga naa mo ana, eh, ipaubos nimo, di ba ang siso kay na ay duha ka ana. Okay, so this is siso. No? Example of that siso is the sulfur tetrafluoride. So in this one, how many bonding domains? Kwintaha. That's 1, 2, 3, 4. Way labot ang lone pair. No? 1, 2, 3, 4. Okay, that is it. Then, how many non-bonding? Katong lone pair o saka. Basta lone pair gani non-bonding na siya. Katong dili lone pair, katong na-attach with other atom at the central atom is the bonding pair or bonding domains. Then we have the ClF3. It is in a T shape. No? This is your chlorine. Then you have tuluka fluorine. Na? Pero naade siya duha ka lone pair. Kaning that one here is known as the lone pair. So what happened here? Therefore, how many bonding domains? That's 1, 2, 3. 3 ra. The non-bonding domains, katong lone pair, katong 1, 2. Okay? Then we have xenon difluoride. Xenon, this is your xenon. Fluorine here. Xenon na siya. Then we have the fluorine here. In the xenon difluoride, it has 3 lone pairs. Therefore, how many bonding domains kanira? 1, 2. The non-bonding domains, there will be 3. That's 1, 2, 3. It is in a form of trigonal bipyramidal. No? So how are we going to predict now the molecular geometry? No? Always remember there are 2 distinct geometry. That is the axial katong pataas, na axial kani-kani. Kana, that's axial. Kana, na, that is axial. Kana o kana, that's axial. Sa taas ra. Na? Then, equatorial, that's equator. Don't you not know that Philippines is in the equator? That is why we don't have snow. Oh, yan na. Kaya na. So, mga Asian countries, kasagari, wala siya. Kaya naman, dili man tadapit sa dool sa North Pole o sa South Pole. Naa siya tas equator. Mini equator na tunga. No? So, duha ra gyud kabuk geometry. That is axial katong ibabaw. Kumingon pa katong nas North o South Pole. No? Then the equatorial meaning at the tunga, at the center, equatorial. So, lower energy conforms resulting from non-bonding electron pairs. So what's the non-bonding? These are the lone pair, no? In the equatorial rather than axial position. So mostly of the non-bonding is in the equatorial. What do you want na sila axial? For instance, this one, that's SF4, no? So it is this one, no? SF4, that is kaniyang axial, no? This is kaniyang mo equatorial. Okay. No? That is SF. So SF4 has lone pair, has 1 lone pair or non-bonding domain. So there will be 4 bonding domains and 1 non-bonding domains. And the last one is the octahedral. There are 3 geometry of the octahedral. So kanisha octahedral, the normal, then the square pyramidal and the square planar. Okay. So example here is SF6. Ma'am, pwede di ay ni siya? Yeah, this is exemption. Kaya pagtunan niyo itong upat ra gyud, parang CH4, these are exemptions already. Okay, so this is the octahedral, na? Ang octahedral na ay upat ka equatorial o duha ka axial. So, ang bonding domains niya is duha sa axial o upat sa equatorial. So, there will be 6. And there is no non-bonding domains. That is SF6. For BRF5, it is a square pyramidal. Okay, square pyramidal in a way that how many bonding domains? That is 1, 2, 3, 4, 5. No? Okay, now siya lone pair. So na siya usa ka non-bonding domains. And the xenon 4, no? Xenon tetrafluoride, there will be, no, 4 bonding domains. That's 1, 2, 3, 4. Then we have a non-bonding domains kay naa siya duha ka lone pair kana 1, 2. Okay. So that is the molecular geometry now of your octahedral, no? So let us now predict molecular geometry in a large molecule. For instance, we have it here. This is CH3, no? This is CH3, COOH. Actually, this is ethanoic acid. CH3, then kani pag yun C double bond O, then OH. So how are we going to predict? It should be by imo na siyang what you call this, usa-usa, no? So this is the CH3, then we have, this is the CH3, then ipang separate nimo, then the O, C, the carbonyl group, and the OH. So, kani pila ka buk electron domain. So, there will be 4. Asa man? 1, 2, 3, 4. No? Kanina po, pila ka buk electron domain? Tulo. That is 1, 2, 3. Kani, pila ka electron domain? That is 1, 2. Apil baya ang lone pair? No, that's 3 and 4. No? So, this is, unsa man yung shape ani? It is tetrahedral. No? Kani, unsa man yung shape ana is the trigonal planar. Unsa shape ani? It's still tetrahedral. So, that is how are you going to predict for a large molecule? Because this is already a large molecule. Kanina tanan. So, you are going to shift it by segment. Na? So, the first segment, second segment, and the third segment. Okay, so this will be your assignment. Okay. Let us move on to polarity. What do you mean by polarity? Non-polar or polar. In what way? The first one, in order for you to know if it's polar or non-polar, especially kung di ka kabalok organic compound man na siya o dili organic compound, we tend to use the what? The electronegativity. Okay, so we will discuss it later. That is, what's polarity? This is a separation of electric charges leading to molecules to its chemical groups having electric dipole moments, with a negatively charged end. Ang end niya is negatively charged, and positively, duha ka buk end niya, negative or positive end. No? Because it is an ion. Di ba ang ion na siya positive or negative. Okay. So, the overall will be equal to 0. No? Overall dipole na siya. No? Okay. So, here it is. It is HCl, hydrogen chloride. No? So, how will you know it's polar? That is 3 minus 2.1. This hydrogen. And this is chlorine. Mato sa periodic table niyo makita na asa pinakaubos na siya mga electronegativities niya. So, for hydrogen, the electronegativity value is 2.1. For chlorine, it's 3. So, 3 minus 2.1 is 0.9. So, naaman na siya range. Asa tong range ani? Basta ang range niya is, na siya range nga, ubos siya o, it's lesser than, the range here is, if it is lesser than 2, I think, is polar. Okay. More than 2, it's non-polar. Okay. Take a look here. So, kanina po, the CCl4, it is, your carbon is at the center. That's black one is 2.5. Then your chlorine is 3. Okay, but there are how many? 4 man siya. So it is a non-polar. This one is polar, non-polar. Sobra's 2. Okay, pero kuto ba na siya 4? Kuto ba na siya 4? Then this one is a polar because that is 3 minus 2.1 is 0.9. This one. This non-polar also. This is polar. Nga naman, because 3 minus 2.1 is 0.9. Okay. So that is how we are going to know its polarity. So for the intermolecular forces, what is intermolecular forces? This is a kind of a bond. The force bond, the bond that exists, the one that holds the bond, that's the IMF, intermolecular force. So it's a force that exists between atoms and molecules, weaker than intramolecular force. Ang intra could either be ionic or covalent, but IMF, it should be covalent bond. So kung entra gani, pwede siya ionic or covalent band. But for the enter, it will be a covalent bond. Ionic is when metal added with a non-metal, di ba? Okay. So this is a strong intramolecular force. Kani dapit nga part. Pero kung walayo na siya kaning chlorine to hydrogen, it is a weak intermolecular force. Okay? Chlorine, hydrogen. Kani hydrogen to chlorine is a strong, it's a covalent bond, no? Strong, and kaning ana part is weak intermolecular attraction, no? So here are different, no? Different substances and its bond. Tanaw nato kinsa ang na kinsay dakog boiling point o melting point, no? I-compare nato. Unsa man nga mga bond. It's under chemical bond. There are two, no? Two ang kasagari, that's covalent and ionic, panagsara ng metallic. Okay. So, for instance, covalent bond of carbon in a form of diamond. Okay. Once it will form with other non-metal, it has a melting point of 3,800, boiling point 4,300. But if it is a metallic bond, for instance, beryllium with another metal, that is lower iyang melting point, no? Lower po iyang boiling point. But for ionic bond, that is a metal added with a non-metal, ang iyang melting point mas lower. So if we are going to look into this, meaning ang covalent bond has a higher melting and boiling point, followed by the metallic bond, and the least is the ionic bond. But for the IMF, there are three types of IMF. That is the dispersion force, we have the dipole force, and the hydrogen bonding. So the dispersion force is, for instance, example is for in the nitrogen N2. Tanawa. Mas gagmay ang in the intermolecular force, gamay iyang melting o boiling point compared sa chemical bonds nga covalent, ionic, and metallic. No? So, pero mas taas ang melting o boiling point sa hydrogen bonding under IMF. Nga naman, because your hydrogen bonds with oxygen. Hydrogen bonding will form if there is hydrogen and oxygen in a molecule. Hydrogen, oxygen, and hydrogen and the halogen. Hydrogen and halogens, pwede po siya. But in most cases, that's hydrogen and oxygen, hydrogen and halogens. What are halogens? That is chlorine, fluorine, bromine, iodine. Okay? So this is just a way of showing you that the chemical bonds have a higher melting and boiling point than intermolecular forces. So there are three types of IMF, as we can see here. That is the hydrogen bond, dispersion forces, dipole attraction. So dispersion forces and dipole attraction are commonly called as van der Waals forces. Kaning duha, dispersion of dipole. Van der Waals din na siya? Yeah. So it could either be dispersion and dipole. Then the second one is the hydrogen bonding. So this is a type of an attraction between hydrogen and polar compounds. Pero choosy siya, In most cases, hydrogen and, as I have said, halogens. Then halogen, for instance, chlorine. Then hydrogen and oxygen, and hydrogen and nitrogen. Kana ra gyud siya under hydrogen bond. Kung nga kag hydrogen and sulfur, dili na siya hydrogen bonding. That's that part. So Non-bonding electron pairs are nearby small electronegative ion of atoms. Usually, kaning fluorine, oxygen, nitrogen. Na? So, these are strongest. Sa IMF, kung sa IMF, but not for the chemical bonds. Ang pinaka-strong na chemical bond is, unsa man? It is the covalent, followed by metallic and ionic. No? So comparing how the strength of covalent chemical bonds and intermolecular forces, mas strong ang chemical bonds. No? Okay. Ang pinaka-strongest sa chemical bonds is the covalent bond. No? For the IMF, ang pinaka-strongest is the hydrogen bond, followed by the dipole, and the least is the dispersion. Kani is, ang pinaka-strongest is the covalent, followed by metallic, the least is the ionic. Remember that. Okay. Na? So, the strongest IMF, kani may strongest IMF, that is fluorine to oxygen, na? Then hydrogen to fluorine, then hydrogen to oxygen, hydrogen to nitrogen. Mao na siya special type of a dipole attraction, which is the strongest under IMF. Okay. How about dispersion? What do you mean by dispersion? No? So dispersion is a temporary attractive forces that result when electrons is between two adjacent atoms that occupy positions. No? This is just a temporary force. For instance, helium, no, one and another helium here. No? Okay. So what happened is there is a temporary force between these two. No? That makes it na partial negative, partial positive, partial negative, and partial positive. But later on, weakranisia. Na? That is for the dispersion. So the weakest IMF is the so-called dispersion. No? Another term for dispersion is the London dispersion force. Mo na pinaka-weak under IMF. So, example of dispersion force, when A combines with atom A combines with atom B, na? So what will happen is, due to electrostatic attraction, no, temporarily it will attract, but dali ra siya because it's temporary, no? So, for instance here, two helium atoms, no polarization. Then here, instantation later on, no, it will have an attraction, no, by means of instantaneous dipole on atom B. Then, ma-induce na po ang atom A. Hinay-hinay lang yun ang ilang, what you call this, attraction between this. Because this is a London dispersion force, ang attractive force nila. No? So, a dipole-dipole, ganina kay London dispersion. Na? Kani, a dipole-dipole attraction is attractive force between polar molecules. No? What are polar molecules? No? For instance, the organic compounds, they are polar molecules. Organic compounds are polar molecules. So similar in origin hydrogen but weaker. Na? Weaker ang klase. Na? So it will increase if you are going to increase its polarity. So for instance, this one, that CH3CN, that is, this is methyl cyanide, this one, in a form of solid. Then this one, this is methyl cyanate in a form of liquid. Okay, so naay gamay nga IMF in a form of a dipole. So attractive dipole force in red, kani, kana, na. Then here, repulsive. Pag mag-attract, ay, positive man ni siya o kuan. Repulsive na pod mo repel, no? So the blue one is the repulsive dipole force, no? So this is in a dipole attraction. Actually, this is just a temporary attractive force, no? So the dipole attraction for molecules approximately equal in mass and its size, and the strength of IMF, intermolecular attraction, increases using your polarity. If you increase your polarity, it will also increase the attraction. No? So here, for instance, the propane, no? Boiling point is 231. No? The dimethyl ether, boiling point, nagkasaka 248. Then we have the acetaldehyde, tanaw ang molecules niya. Pareho ra gani ang polarity magod. Pareho nga molecules, carbon, hydrogen, no? So, boiling point is 231. Kanina po, carbon, hydrogen, nana po oxygen, na? So, magka-increase gani iyang polarity, magka-increase po ang iyang attraction, the IMF. Kani po, that is, na? Carbon, hydrogen, hydrogen, carbon, carbon, hydrogen, hydrogen, oxygen. It is increasing. Na? Kani pila na ka molecule, na? Tulo na. Kani kay usa na-add og oxygen, kani na-add na pod og carbon og nitrogen. So it will increase depending on its polarity. No? What do you mean by another force under IMF? It is the ion dipole. Okay? Take a look. No? It is hydrogen bonding una, then dispersion, then the dipole. Okay. Here, we have the dipole attraction is siya. Na? Here is the ion dipole. Na? Exists between ion and a polar molecule. Kaning dipole na, o dispersion, it has something to do with na, the polar. Na? Polar molecule, polar atom. Kanina, if there is a presence of an ion. Okay. So, exists between ion and a polar molecule. For instance, sodium ion and chloride ion. Na? So, that is it. So, as a summary, no, in case there is ions, no, kung naa siya ions, unsa man siya, no? Kung naa siya ions, yes, they are polar molecules, no? Kung naa siya ions, pangutana dayon, are they polar molecules? If it yes, unsa nga klase nga, no? IMF, it is an ion dipole force. Pero kung wala, gani siya polar molecule, meaning, for instance, it is na, metal o non-metal, it is ionic bonding. Pero kani siya gani, kung puro gani siya non-metal, no? Non-metal gani siya tanan, it has a tendency that it's a polar molecule, ha? Kung kani, na, kung ang ions present, kung naay by ions is naay charge. Kung na siya charge, if it is yes, sunod nga pangutana. Polar molecules ba siya? No? Kung polar gani, meaning all are what? No? All are non-metal plus non-metal. No? Okay. No? Kung naay polar gani, no? What happened? If it is yes, kung naa sa imong molecule naay polar molecule, if it is yes, what kind of, no? What kind of a force is that? It is an ion dipole. Example, this is sodium positive, chlorine negative. So it's an ion. Pero gidissolve man nimo siya sa water. So it's naanay hydrogen bonding. So it is an ion dipole. Kani wala ni mo siya gi-dissolve sa water. That is potassium bromide. It's metal and non-metal. Then ammonium nitrate. Okay. No? So it's ionic. No? Ionic bonding ani. Then if it is no, walay ions, no? Is it a polar molecule? Nabay polar molecule present? If it is yes, so nabay hydrogen bonded to katong nitrogen, oxygen, fluorine. Okay. Kung naagani, it is a dipole-dipole. No? Kung wala gani, it is a dispersion. No? Tapos na pod, na kung naa ng hydrogen to nitrogen, hydrogen to oxygen, hydrogen to fluorine, if it is yes, it is a hydrogen bonding. So that is how you are going to classify the forces of attraction. It could either be, the first one is a chemical bond. It could either be in ionic, covalent, and metallic. Then the other force is the IMF, the intermolecular force, which has 3, the hydrogen, then we have the dispersion and the dipole. Okay, that is how you are going to look into it. Unsa nga band ang pinaka taas og strength? Of course, it is ionic bond. Increasing ni siya, ha? No? The weakest is the dispersion. The strongest, the highest strength in the bond strength is, or in the attraction, is the ionic bonding, followed by the ion dipole, followed by hydrogen bonding, then dipole-dipole forces, and the dispersion. Okay, so let us move on now to the hybridization of the atomic orbitals. What do you mean by hybridization? These are covalent bonds that form from overlap of 2 orbitals. Covalent bond. Covalent bond is a non-metal added with a non-metal. For instance, hydrogen and hydrogen. You will form H2. Okay. That is a covalent bonding. And orbital overlapping. How will you know there will be overlapping? Okay. For instance, this one, orbitals overlap to form covalent bond. Overlap meaning i-share niya. Di ba kani? That is one hydrogen gani o another hydrogen. So that is, pila maximum kung hydrogen? 2. So, 1 electron sa usa ka hydrogen, another 1 electron sa hydrogen, they will just share. So, naa siya overlap nga niya. Kaya nga naman, nag-share sila sa duha ka electrons. Ang usa ka hydrogen atom o another hydrogen atom. So, here, hydrogen and chlorine. Hydrogen, kadumdum pa mo unsa ang orbital sa hydrogen? That is 1s1, di ba? Okay. Ala, ang 1s1. Katong iyang number of orbitals. Can you still remember the electronic configuration? That is 1s1, 1s2, 2s2, 2p6, like that. Okay. Then, you have chlorine. Kadumdum mas chlorine, pila man ang chlorine? What's the atomic number of chlorine? The atomic number of the number of chlorine is pila? 7. Diba? So it will be 1s2, 2s2, then pila man? Sunod, 2p, 7 man. 1s2, 2s2, then 2p3. Okay, that is for chlorine. So there it will be 7. So what happened here is, chlorine is pila man ang kuan niya? ang iyang atomic number sa chlorine. I think it is, chlorine is 17, like that. Okay, nato, pinakataas mo siya. Kuan na nga to siya sa side, no? That is, hydrogen is 1s1, no? Then chlorine is 17. If it is 17, that is 1s2, 2s2, then 2p6, then 2p6, no? 10 na. Then 17, and the last one is 3p, 3s1, no? 3s1, then 3p5 man siguro ni siya. Okay. So, what happened here is your chlorine is in 3p. Okay. No? It's in 3p. No? So, if you have duha ka chlorine, that's 3p and 3p. Okay. No? So, it is an sp hybrid. Nganong sp man? Nganong sp man? Because your hydrogen is an S and your chlorine is a P. No? So, there will be two sp hybrid orbitals. No? What will happen here? No? Two sp hybrid orbitals kay ang imong hydrogen is S, ang imong chlorine is P. So sp hybrid orbital shown kanina ang iyang formation. No? It is an sp hybrid orbitals. Duha ka, no? Kaninga ni A is now your, kaning tunga ninyo, this is the S and this is the P. Okay. For instance, for the beryllium, mo ni ang beryllium, no? And this is your fluorine. Okay. Your fluorine is in P also. Therefore, you will have an overlap here of the S and the P. Okay. Beryllium is S. S ang beryllium, no? S orbital. Ang F nimo is P. Okay. So there will be a 2p orbital here, no? That's fluorine, beryllium, fluorine. Duha ka P kani ang S, no? Then duha gyapon ka P. So it will be a 2p atomic orbital. Therefore, you will have this one, na 2p here, na wherein your beryllium will be, no, it will be a hybrid already. Okay, field maning iyang, na field man iyang 1s, field po ning iyang sp, ang wala ma-field is ang 2p. So this will be an sp, dili pwede ning 2p, it's an sp ni siya, sp. Wa pa man ni ma-field ning 2p orbitals, na? So therefore, kani nga part kaniya, that is a 2s, then this is a 2p. Ang mahitabo kay aron ma-fill ni siya tanan, no? Mo transfer ni siya kaning usa ka electron nga ni mo transfer nganha, kaning usa nga niya mo transfer ngadto, no? That makes it a 2p. No? So this 2p is already a hybridized, no? So that is sp2 kani 2p, no? 2p, then ang hybrid anak niya is hybridized into, no? Ano isa ka ikuan? Ang makitaan. Hindi ko makita. Okay. Ayaw sa balik ta. Okay. So what happened here is, di ba, as I have said, kaning S2, S ni mga niya, ang usa ka electron is mo transfer ngan hi, kani pod mo transfer ngan ha. No? So, this will be promoted into 2s and 2p. Okay. Therefore, this is now a 2p hybrid orbital. Okay? No? But not all of it will have this kind of formation. Naalang yun na siya yung mga so-called exemption. No? So that is for the sp2 hybrid orbitals. No? sp2 hybrid orbitals. For the sp3 hybrid orbitals, how it is being done? No? For instance, you have your NH3 here, no? So this is now your Lewis structure for this, no? Then this is the VS pair. So looking into your table, no? Into the hybridization, this will be promoted to sp3. Katong ganina, this will be promoted to the sp2, no? Kani po ni siya, the NH3 or the ammonia, it will be promoted to the sp3 hybridization. So once you know the electron domain, you will also know the hybridization here. For instance, this is beryllium and fluorine. It is also may orbitals niya. That is, ang beryllium is S. Ang imong fluorine is P. So that is sp. So you will have 2 sp. Ani, do ka 2 sp, no? Same thing gyapon na siya sa ngano 2 sp man. Usa ka S og ang F nimo duha man duha ka P, na? So hybrid orbital set is duha ka 2 sp. Ani, pareho ra ni siya nga niya. Mercury is S, then chlorine is P. Duha ka buok, it will have 2 sp. Then you have here, kaning beryllium, boron is S. Naamang kay fluorine, there will be 3 ka sp. No, that is spp. Okay. So there will be 3 sp2. Then this one is you have an S. You have an S. Your carbon is, your hydrogen is S. S. Then you have a carbon of P. Therefore, that is sp. But kay lone pair man, nag-lone pair, what happened here is in a tetrahedral, that's CH4. No, CH4 is upat ka hydrogen, diba? Then you have carbon here. That is an spp. Therefore, how many hybrid orbitals you will have? 4 sp3. Okay. Nga man, this is the first sp3, this is the second, third, and the fourth. Okay. So that is the hybridization of atomic orbitals. So this will be your assignment, knowing the orbital hybridization of the central atom. So how many bonds do we have? Actually, a single bond is head to head. Single bond is sigma bond recognize siya. That is head to head. This one, head to head. It's a sigma bond. Then pi is side to side. Okay. This is a sigma bond. This is your molecule, then kana anha. Head to head meaning kung mag-double bond na gani siya, it is pi na ng ikaduha nga double bond. Okay. So here it is. If this is one bond gani, that is a sigma, because it is head to head. Kana. Then kani is double bond, usa ka sigma bond na apoy usa ka side bond, which is a pi. So ang double bond di is usa ka sigma bond o usa ka pi bond. Ang single bond usa ra gyud ka sigma. Ang triple bond usa ka sigma bond o duha ka pi bond. Did you get it? Let us look into resonance. What do you mean by resonance? It has something to do with the structure of a molecule nga pwede nimo siya into different forms. Ang pinaka best nga example of this structure is known as benzene. Now, benzene ring. Now, benzene has a formula of C6H6. Okay. C6H6. Nakani-kani. Unom kasi 1, 2, 3, 4, 5, 6. Kung unom po ka-hydrogen, pwede din na siya yes, labaw mag-organic na mo. Kaning hydrogen nga niya is na ay double bond. Kani nga hydrogen nga niya to carbon is na ay double bond. Kani na apoy double bond. No? So, pwede nimo siya i-write into this. In a benzene na ase tulo ka double bond. So, pwede nga ana, but it is in adjacent to each other. Meaning, na ay usa ka double bond nga niya, wala. Na po double bond, wala. Na po double bond, wala. Okay. So, pwede po nimo siya buhaton nga ana. Kani. Or, aron sayo na lang, you can write that into a ring. That ring there, meaning the double bond here is being shared from each of the carbon. Na? So that is what is meant by resonance. Meaning, kung isuwat nimo siya ing ani nga formula, correct yapon kana, correct yapon kana, correct yapon siya. Na? And that is resonance. Why? Because the atom are moving. No? So they are delocalized. No? Meaning, mag-shift siya. Delocalized is mag-shift siya. No? So it dili ang sigma ha, it's only the pi. So the pi electrons in benzene are not localized but delocalized. Pwede siyang mo shift. No? So it's the pi. So mo shift siya. So it is localized and that is why it will produce different structure. But the same na siya by means of resonance. Same thing with, kanus ama na siya may tabo. If naa siya double bond or triple bond. Diba? Kini is nitrogen trioxide. Okay. Nitrogen trioxide, this is the formula. First formula. 8. Ang nitrogen, di ba, there should be 8 electrons. So, pwede nga na ang double bond. Kaya pareho na siya nga oxygen. So, this is the first formula. Then, pwede po ang double bond na ang anhaa. Kana. Pwede po ng double bond na ang anhaa. So, usay patawag ani, they are resonance. Why? Because the electrons are delocalized. It is moving. Okay? That is what is meant by resonance. Resonance meaning they have the same, that is NO3. They have the same formula, no? Molecular formula. But if you are going to write its structural formula, no, it will have different structural formula, but they are still the same because of the presence of the double or triple bond. No? Okay? So how about, pero kung CO2, dili pwede. CO2 is, duha man kabuk double bond ana ra. Di siya ma-delocalize. Ma-delocalize meaning ang electrons nimo dili siya pwede mo shift. Na? And that is what is meant by resonance. So that ends our lecture, and I hope you have understand our lecture. So thank you for listening and have a pleasant day. Okay.